Hi everyone, welcome to a new tutorial for using machine learning for biomedical data. So in last tutorial we used Caret for classification, so today we'll use Caret for regression and we'll explore some extra parameters with Caret. So let's load Caret and other packages. So today we'll use do parallel. Do parallel allows Caret to run in parallel without extra effort. So today I'll show you how to use do parallel or running Caret in parallel. So today we'll use the Boston housing dataset. It's a dataset of 506 samples with 14 columns, and the last column or feature is our target feature. So we'll train our dataset to predict the last column. So let's first, as in the last tutorial, we'll use train control similar to the last tutorial, but today we'll add one more parameter, which is allow parallel, and we set it true so that the Caret package can run in parallel. The next thing we'll need to do is set our cluster. So today with this function, we set our cluster to two clusters based on the available CPUs. Actually, it's not two clusters. It's the number of cores or CPUs that we are going to use. In this case, it will be simple. Just I will use two CPUs. Then I will register my cluster. So Caret can look into the system and understand there's two CPUs available for it. Then we'll use Caret list. We set it to predict this variable, the median variable that's from our data set. So you can read more about the data set, but basically you are interested in predicting this column. Then we'll use the regular preprocessing, scaling and centering for each feature, and we'll use the four machine learning methods: GLMNet, KNN, random forest, and SPM radial. After executing this algorithm or this function, so we turn off the cluster. So now Caret runs in parallel, and we'll wait a little bit until we get the result. Now we can look at model correlations across the four algorithms, and we can look at the summaries in terms of mean absolute error and root mean squared error and R squared, the explained variance in our data set. And so this will give us overview about the performance of each method. It's not our interest in this tutorial like to compare the methods, but we are interested in looking about the capabilities of Caret package. Then another thing we can look at it in this tutorial is the variable importance. So with our Caret, you can really look at the important variables in your data and scale them based on their importance. So for this, using var importance, we can look at the variable importance, and we can look at that across different algorithms and see whether we can get the same like importance across each method. So this will give you like overview of what are the important variables that are contributing to predicting your outcome. Now, also I want to introduce another feature in Caret list. So let's say you want to apply PCA before one of your algorithm. Basically, can be done using Caret model spec, where you can identify what you want to do uh, with specifically what you want to do with that algorithm or that algorithm. So let me show you how you can do it. So as in previous command, we used method list, but now I want also to try random forest with PCA. So now I will ask Caret list to run random forest. So I will call it a random forest PCA. So it should be a list. Then random forest with PCA is the name, and then Caret model spec function. Then I will specify my algorithm, then the pre-processing set, and one of the pre-processing sets or configurations is PCA. So basically, we can look at the uh, pre-processing, and we can see what are the available options here. In this option, I chose to use PCA, but you can choose any other configuration. So in this example, I'm going to ask Caret to run a random forest with uh, by first applying PCA on the data, then running a random forest. And uh, I want to run PCA and retain the top 10 PCs in the data. Actually, you can configure like to use the 95% explained variance, the top PCs that explains up to 95% of the explained variance. I can show you later how to set this up. Let's run this. Now you can look at model correlation, and we can see that now we have random forest with PCA. We want to see whether, like, in some applications, if you have really large data set and like high dimensional data, you might want really to ease the training process by applying PCA before you apply your algorithm. So in this case, we are looking at the model correlation. Also, we can look at the model summary and see whether, like, applying PCA before random forest really improve the uh, outcome or not, or like improve the performance as compared to regular random forest with all features. In this case, it did not really improve the results. Basically, we have really small data set with actually low dimensional data with 14 variables with really low dimensional data. There is no need to apply PCA. So also we can look at some box plot. Basically, we can look at the root mean square errors, another way to visualize the data here. And also another thing, you can look at the optimal parameters from your data set by running the plot on the model. Basically, here we are looking at the KNN, and we want to see what's the best neighbor that will be optimal for our model. Also, we can look at the random forest. Actually, I want to look at the random forest only, and we can see how many the splittings in your tree, what's the optimal splitting in your tree, and you can see here 7 splittings. So this is all for today. I hope you enjoyed this video, and I'm looking forward see you in the next videos.